Hi and welcome to this lesson on nuclear fission. We're going to look at what fission is, what chain reactions are, and look at the uses of fission in reactors and atom bombs. Okay, so fission is the splitting of a large nucleus into two smaller nuclei. This process releases a large amount of energy. Now, it's really important to note that it's nucleus or nuclei, nuclei being the plural of nucleus, not atom. Okay, you can't say it's the splitting of an atom, it's the splitting of a large nucleus. Okay, it doesn't happen on its own. Usually what happens is we need to put an extra neutron into the nucleus, and then that causes it to decay into two smaller nuclei, which are roughly equal in size, and then 2 or 3 neutrons and some gamma rays are produced as energy, and they've all got kinetic energy. Okay, the neutrons that are produced might then hit more large nuclei, which then cause those nuclei to fission. And we call that process a chain reaction. So when the neutrons from one reaction, one fission event, go on to cause another fission event. In a nuclear reactor, we control that chain reaction by using something called control rods, which absorb the neutrons. So if you raise the control rods, you have less being absorbed, so more reaction can take place. But an atom bomb has no control in it. Okay, so have a go, pause the video, and have a go at answering these 7 questions. Then we'll go through the answers in a moment. Okay, so what do we need to do in order to start a fission event? Well, what needs to happen is the nucleus has to absorb a neutron. Okay, the products of nuclear fission are 2 smaller nuclei, some neutrons, and energy, or you could say gamma rays. Okay, what is a chain reaction? So you need to say that a chain reaction is when the neutrons produced in one fission event cause more fission events. How do atom bombs create such large explosions? That's because the reaction is uncontrolled. The chain reaction is uncontrolled. And then how do we stop explosions in nuclear power plants? We do that using control rods. So if we wanted to speed up the reaction, as I said before, you would raise the control rods. So less neutrons are being absorbed. And if we wanted to slow down the reaction, then we would lower the control rods so that more neutrons could be absorbed and the reaction doesn't take place so quickly. Okay, have a go at the PEQ on nuclear fission. Pause the video for a moment, we'll go through the answers when you're ready. Okay, so for question 1AI, a nucleus, not an atom, a nucleus is hit by a neutron and that splits it into smaller nuclei and neutrons. Then for part II, you needed to show a diagram with the neutrons being produced by the fission going on to cause more fission, and you need to show or label the dorsal nuclei and the neutrons in that. So the dorsal nuclei are smaller than the original one. Okay, so the main issue is that the cost of building and decommissioning is very high, or the cost of building is higher in a nuclear power station. Decommissioning just means taking the nuclear power station offline and getting rid of all the waste products. In terms of advantages, because it's got a high energy density in nuclear fuel, there is less pollution from transport carrying the fuel, or coal produces more pollutant gases, or you can refer to carbon dioxide or sulfur dioxide. You can say there is actually more radiation pollution from coal than nuclear. You can say there's more waste from coal than nuclear. But you do not get any marks if you talk about burning uranium, because it doesn't burn, it fissions. And you have to give details of the gases produced if you're referring to global warming or acid rain. Right, your last task for this lesson is to do a piece of extended writing for me. So you need to describe the similarities and differences between a nuclear power plant and an atomic bomb, and then you need to submit that on Fronter. Okay, good luck. I look forward to reading them.